Hey, this is Clint Halstead, and this is the third video in a series on a step-up converter using CAD. So now what we want to do is take this design and create some Gerber files. So I made a list of things that we should do. Make sure you pass all design rules. That's the first step before you do your tape out. So tape out just means that we're going to send these to the board house for manufacturing. So what we do is we go to design rules here. You can change all your settings. Main important thing here is sizes, your clearance from wire to wire, pad to wire. Just make sure you fill these in according to whatever board shop you're using. Click check. You can see down here at the bottom it says 20 approved errors, so I don't have any errors that are unapproved. Make sure you fix all those errors. Next step, make sure you don't have any air wires. So to do that, just turn on unrouted, and if you do have air wires, then they'll show up on here as being lines from one point to another point. So make sure those are all gone. One way to guarantee that is just run the auto router. If you just if you do top and bottom, just run the auto router. It'll tell you down here 100% finished. So that just means that you have no unrouted wires. Make sure all your vias and pads have the minimum size that you need. Make sure you have a ground and power plane, and make sure those are named. So in this case, we have a ground plane. You can click here and make sure it's got the right name. Print your bottom layer on a sheet of paper and check that your components fit. To do that, File, Print. Make sure you do scale size of 1. You can do black. Just hit print. You can change this to an actual printer that you have, and just print that, and then just check all your components, make sure they fit. Next thing you want to do is at the end, archive your files. Just keep track of revisions by just renaming your files, and at the very end when you get done, best thing to do is just select all your files and then just zip them up. That's the best thing to do. So just find your files. In this case, we're doing some CAD training videos. So just select all your files, send to compressed zip folder. So it's very important that you do this when you tape out. Not you don't want to wait, because you may wind up not having your files. You may change them, or they may get deleted. You don't want to edit them and then not have your design. Next thing is you want to renumber all your components. It's pretty important to do this. So a lot of times you may have a bunch of names in here, numbers that are very long. Maybe you've placed them several times. So best thing to do is just renumber those. So click ULP. Renumber. Click open. Just click OK. It'll renumber all those for you, and it'll also annotate those to the board. Very important that you should do that, especially for very large designs. Create your silk layers using silkscreen.ulp. So what we can do is go to your board, and please note that some ULPs don't run in the schematic and some don't run in the board. So if you're trying to run a ULP and it's not working, go to the other part of the design, either the board or the schematic, and it may work. So okay, so you can download SilkGen off of SparkFun's website. You can probably type SparkFun SilkGen. used to be on there, .ulp. Anyway, just look for that. I think it's right here. You can see right there. There's a silkgen file. So just look it up on the internet. The one that comes with Eagle is not very good, so you need to get the one from SparkFun. silkgen ULP. If you pull this up, I don't think this is the right one. So let's try this again. silkgen, maybe 2. Okay. It may be somewhere else. Let me go to a different location. Okay, so let's try this again. silkgen. Open. Okay, so it should look like this. Try to find that file online. silkgen, so the reason you want this utility is because the regular silkgen only pulls in tplace and tnames. You also want to get your values and your document layer. So then you can just click generate and see what it did is it created this yellow layer. So now you can turn off, it created T-silk and T-bottom, so you can turn off all the other layers and just look at your silk layers. So this is what it generated. You can turn off the bottom one and you can just turn on the top one. So there you go. Now what you want to do is typically what you have on a very dense design is you'll have all these sort of overlapping on top of each other and you can't read them. So you need to make sure to space them out. Space them out, move them around, do whatever you want with them. You can add things here. You can delete things just like you can in any other utility. You don't want to move the ones away from the edge of the board. Make sure you have polarities here. Notice this part, you know, if it didn't have a reference designator or something, then you could just, you know, draw a little circle or a pin 1 indicator. Like if I wanted to do a pin 1 there or something like that, or if I wanted to just use text, I could just put a 1 here. Okay, I could just say, yeah, that's pin 1. So if you have a connector, so for example, this connector doesn't have any markings on it, so I can just put a 1 there. That'll tell me that's pin 1. This diode has, you know, has very visible, this has a very visible polarity. So just make sure you have all that working. You know, rotate things the way you want them. Once you get it all cleaned up, then you're good to go. So now, what's the next step? Remember, we did the silkgen, we turned on the T-dock and the B-dock. The reason we want the T-dock and the B-dock is because that usually has, let's just go to T-dock and B-dock and see what they look like. It has other information on there other than T-place. A lot of times it has actually the diode information on it, so that's good to have. Okay, so now we can sort of just turn on our regular stuff. We don't really need T-place and T-values anymore because we're not going to be using those for fabrication. We're going to be using our silkscreen layer. So we don't need those T-place, T-origins, T-names anymore. You can turn them on, it's not going to affect anything, but when we generate the silk, when you generate the silk, or generate your Gerbers, then you're going to use that silkgen layer. So make sure all your components have pin 1 markings and polarity markings. So now it's time to generate your Gerbers. So let's do that. Go ahead and click this CAM file, and you want to do File, Open, Job, and then, you know, you can save these files. This is one I've been using for a while, Gerber274.cam. That's the standard one that you can pull in. The one that I use is one that I've made for myself. And if I open that up, it has all the layers that I need. And you can add layers. You can just say File. You can add. Just click Add Layer. See, if you click Add Layer, it just adds. It added another layer. So whatever layer you're on, it'll just copy that one. See, if I'm on Component, if I click Add, it adds another component, and then you can delete it. So each one of these tabs will actually be a file. And you can see every time I click on the tab, it changes this extension name here. And you see that I've put a default location. You can change that too. You can actually you can completely get rid of that and just leave it like this. And then it'll just put it in the current working directory, whatever, because I'm currently working out of this directory where my project is at. Another thing, so that's one option. Another thing that I like to do, instead of putting it in my current working directory, I like to put it in this folder called Gerbers. So what I usually do is just add, I come here and I'll just create a new folder called Gerbers. And then it won't put my Gerbers in here with all my project files. It just creates a blank folder for me. So I can just just do that. So come down through here and add that extension there. To each one of these. And then you can save this, and then you don't have to do this each time. You can just do this one time. So if you don't have this file already created, go ahead and make sure you have each one of these tabs. You want to have, and we'll go through each one. So the component side, I call it comp. It doesn't really matter what you call the extension, but just try to be consistent. So if you click over here, one weird thing about this utility is you can't really see what's selected until you sort of scroll this mouse thing. Now, this file is going to get whatever you click on over here. If I click on this, it's going to grab that layer and put it on this file as a picture file. So what I'm saying with comp, I want everything that's here, top, pads, vias, dimension, I want on my comp layer, component layer. Okay, so solder side, this is bottom, pads, and vias. Silkscreen, you see right here, it's actually not grabbing anything right now. So I could just enable my silkscreen layer. And so it's not on there, so what you need to do is make sure you save this. So click save once you generate your silk, because if you don't click save, it won't be able to find it. So now let's do this over again. Click cam, go open job, go to your, you could do Gerber 274, or you could go to the one that you've created, open. This is the one we were working on. When you do the silk screen layer, if you come over here, you can see it's got T silk on here. So that's what you want. You don't want T names and T values and T doc and all that. You want only to grab the silk that you've edited. Okay. I think by default it tries to grab a T place and T origins and T names, but you don't want that because those are going to be all mixed up. For your bottom side, your solder side, you can grab B silk. Solder mask, T-stop, stop mask on the solder, B-stop, outline is just dimension, milling, if you have any special milling on the internal layers, you have to turn that on. Drills, just make sure, for the drill layer, make sure you select Excel on. Not, if you notice the other ones, they're all Gerb 274. See, these are all Gerb 274. But your drill layer has to be Excel on. And you should call it DRD. And just make sure it's your drill layer, you know, turn on your dimension. That way they know where your edge of your board is. Drills and holes. So, anyway, that's all that. And then you can just say, I think all these are going to go into the Gerber folder, see, because you have Gerber. So we'll just say process job. Can't open Gerber. Okay, I thought that was going to happen. So we need to get rid of that little /. It doesn't need that /. It just wants to know the name of the folder. Okay, so now we can do file save job. That way you can have it for next time. And then just say process job. And then you can go check your folder. See, in your Gerber folder, you have all these files. Okay, so the next thing you have to do, the next step, view the Gerbers. Don't make the files and then not look at them, because whatever you make on your Gerbers is what you're going to get. So if you don't look at them, you may not be getting what you want to get. So how do you do that? You download this utility called GerbV. So you can probably go online, and it's a free open source Gerber viewer. So just download that, open it, and then you can just do file, open layer, and then of course you just have to point to where that's at. So C drive, program files, users. Okay, so I'm going to have mine in my Google Drive, and I'm going to have those in Eagle Track CAD training, step up converter, Gerbers. Okay, so we can just select all these files. And now you can actually turn each one of these on or off. You can look at each one of these. So the drills, that's what that looks like. The outline, the milling layer, there is none in this case. Component side, solder side. So that looks good. Make sure that your solder stop. This is very important because solder stop, this is where you're going to create a mask, and you're going to prevent the solder stop layer, which is basically this acrylic or the spray type film. You don't want that spray on your pads. So this is going to prevent. If you don't have that, then you're not going to be able to solder to your pad. You're going to have to scrape that acrylic stuff off. So make sure you have that. You can see on top and bottom. I'll just turn off this. I'll turn on the solder side for right now. And then you have your silkscreen layer. Just make sure that you have, you have your silkscreen, and this is your silkscreen on your component side, and this is on the bottom side. So just make sure it looks the way you want it to look. If it looks good, you can send these to your board shop. This is all they need. They don't need anything else. Another thing I would suggest is to go to this website, 3D BRD Viewer. Type this in to a web browser, 3dboardviewer.scitech.bg, and what you can do here is just actually, this is pretty simple, just drag your board file, which will be, I think, this one. Drag this one over here, and it will create a 3D image. It takes a little bit to load, but it makes identification of errors really a lot easier to identify. There's just something about being able to see visually the board that really helps you out a lot. So this utility is very helpful in that regards. It does take a little bit of time to load. So once that loads in, then you can see a 3D of your board. You can you can toggle, you can edit the devices and fix those if you want to make those look better. But this is very useful to make sure that the board, looks the way that you want it. Only problem I think is with this, it doesn't really show you your silkscreen, it shows you T-place, so just be aware of that. But you can rotate it and things like that, make sure that it's going to look the way that you want it. So anyway, I believe that's everything. So this is just the end of the training video 3 for the CAD step-up converter. Thanks a lot, and I hope you have a good board building process. Thanks.